Hello and welcome to my videos. My name is Ashish and today we are going to learn about generational ZGC, Z garbage collector in Java. But before, let's go through what is garbage collector and what all types of garbage collectors are there in Java. Garbage collectors in Java are automatic memory management mechanism responsible for reclaiming memory that is no longer in use by the program. Java uses garbage collection to automatically free up memory occupied by the objects that are no longer referenced or reachable, thus preventing memory leaks and simplifying memory management for developers. There are different garbage collection algorithms and strategies employed by JVMs, and these collectors vary in their approach and efficiency and throughput. Here are some common garbage collectors used in Java. Serial garbage collector or serial GC. Serial garbage collector uses single thread to perform garbage collection tasks. It is suitable for single-threaded or simple applications with limited memory resources. It is typically used with small Java applications or as a default collector on client class machines where we don't have small pause time requirements. This GC implementation freezes all application threads when it runs. Therefore, it's not a good idea to use it in multi-threaded application like server environments. We have to pass parameter as use serial GC while running your application, just like shown in the slide. Next is parallel garbage collector or parallel GC, also known as throughput collector. The parallel garbage collector uses multiple threads to perform garbage collection in parallel. It is designed for multi-threaded, throughput-oriented applications where short pause times are acceptable. Parallel GC is often the default collector for server class machines. It is default GC of the JVM from Java 5 until Java 8. If we use this GC, we can specify maximum garbage collection threads and pause time, throughput, and footprint, that is heap size. In this example, you can see how to use. You need to pass use parallel GC in command line parameter while using when you want to use parallel garbage collector. Next is CMS, that is concurrent mark sweep garbage collector. The CMS garbage collector aims to minimize pause times by doing most of the collection work concurrently with the application threads. It is suitable for applications that prioritize low latency as it tries to minimize stop the world STW pauses. STW or stop the world means situation where all application threads are temporarily paused or stopped to allow the garbage collector to perform its work. However, it can cause fragmentation and may not be as efficient as other collectors for very large heaps. It was deprecated since JDK 9. Next is G1 garbage collector. It is also known as garbage first GC. The G1 garbage collector is designed for large heaps and aims to provide low latency and predictable pause times. It divides the heap into regions and prioritizes the collection of the region with the most garbage, hence the name garbage first. When performing garbage collections, G1 shows a concurrent global marking phase 1 known as marking, to determine the liveness of the objects throughout the heap. After the mark phase is complete, G1 knows which regions are mostly empty. It collects in these areas first, which usually yields significant amount of free space. Phase 2, which is phase 2 known as sweeping. G1 is suitable for server and client class machine and is often recommended for large scale application. If you want to use it, then you need to pass use G1 GC in your command line parameter as shown in the example. Next is ZGC, that is Z garbage collector. Z garbage collector is a low latency collector designed for application that require very short pause times. It can handle large heaps and is suitable for use cases where pause times must be kept to a minimum, such as gaming or financial applications. It was debuted in Java 11 as an experimental option for Linux. JDK 14 introduced ZGC under the Windows and Mac OS. ZGC has obtained the production status from Java 15 onwards. ZGC performs all expensive work concurrently without stopping the execution of main application thread for more than 10 milliseconds, which makes it suitable for applications that require low latency. It also handles heaps ranging from 8 MB to 16 TB in size. Furthermore, pause times don't increase with the heap, live set, or root set size. Similar to G1, Z garbage collector partitions the heap, except the heap regions can have different sizes. If you want to use ZGC, you need to pass use ZGC as a command line parameter. So next we have this benchmarking for ZGC, parallel GC, and G1 GC. And clearly you can see ZGC takes lot less pause time compared to parallel and G1 garbage collector. And it is true for most of the use cases. Next we have is Shenandoah garbage collector. OpenJDK 12 build normally they were included Shenandoah by default. It is another it is another low latency collector designed to reduce pause time for large heaps. It also uses region-based approach similar to G1, but focuses on minimizing STW pauses. It is capable of collecting garbage from 200 GB heap to 2 GB to 2 TB heap. Should have similar low pause behavior. That is, the pause times are no longer directly proportional to the size of heap. If you want to use it, then you need to use Shenandoah GC as a parameter to your command line, as a command line parameter to whenever you start your application. Next is, now we come to the point, generational ZGC. OpenJDK 21 plus include generational ZGC. Goal is to improve application performance by extending existing ZGC, Z garbage collector, to maintain separate generations for young and old objects. This will allow ZGC to collect young objects which tend to die young more frequently. Applications running with generational ZGC should enjoy lower risks of allocation stalls, lower required heap memory overhead, and lower garbage collection CPU overhead. These benefits should come without significant throughput reduction compared to non-generational ZGC. The essential properties of non-generational ZGC should be preserved. Pause time should not exceed 1 millisecond. Heap sizes from a few hundred megabytes to many terabytes should be supported, and minimal manual configuration should be needed. As example of last point, there should be no need to manually configure the size of the generation, the number of threads used by garbage collector, or how long objects should reside in young generation. General belief by JDK developers is that general ZGC will be better suited than its predecessors to most of use cases, eventually be able to replace the latter with the former in order to reduce long-term maintenance costs. If you want to use generational ZGC, then you need to pass Z generational as a command line parameter, and you need to pass use ZGC2 as seen in the slide. The choice of garbage collector depends on specific requirements of your Java application, including factors like throughput, response time, and available memory, and the scale of your application. Modern JVMs often provide multiple garbage collectors to choose from, and it's essential to understand their characteristics to select one that best suits your needs. Thanks for watching my video. Please share, like my channel, my videos. Thanks for watching.